Today we're going to do a video to talk about our special cases for solving equations. Normally when we are solving equations, if we have, say, a double angle or something, we try to use that double angle identity to simplify our problem. What we're going to do today is we're going to see some problems where we don't have a double angle yet or we don't have a squared term yet, but if we make our problem into a double angle, or if we square everything so that it becomes a Pythagorean, that will actually simplify our problem for us. So we're going to kind of work backwards from what we're used to doing. We're going to put things into Pythagorean or into a double angle, but it will simplify our problems down for us. So example 1 looks like this. In this video, I'm not really going to pause so you can write stuff down, so feel free to just take care of that on your end. Looking at this problem, I have sine and cosine. If they're not squared, I can't turn them into each other. So I do want to square this problem so that I can turn it into a Pythagorean and kind of turn them into each other. You can do this problem a couple of different ways. You can square it when they're on opposite sides like they currently are, or you can square both sides of the equation when they're on the same side. And it doesn't really matter. I'll just do it here where they're on opposite sides, and on the next one I'll do it where they're on the same side. It will not affect your answer. It will change a little bit how you have to solve it though. So here I'm going to square both sides of the equation, which you are allowed to do so long as you do it to everything. What that's going to do is it's going to make it sine squared x equals cosine squared of x. And say we want to turn them into each other. You could turn either the sine into cosine or the cosine into sine. So let's say I wanted to turn sine squared into cosine squared. So I'm going to make this 1 minus cosine squared x equals cosine squared x. If I add that cosine over, it's 2 cosine squared x. And now this is a problem that you could have solved before. When we solve it, we know that cosine x is plus or minus 1 over root 2. And then I'm going to solve this for you. It is a 45, 45, 90. It is plus or minus, so it is in all quadrants. So it's pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4 would be my 4 answers. However, there's something we've talked about both in Algebra 2 and I've referenced it during this chapter, and it is the fact that if you square both sides of the equation, which we did here, you have to check your answers to make sure it actually works. So we are going to have to go through and check every single answer. You did this back in Algebra 2 when we would square both sides, and you're going to have to do it now. We're going to check it one answer at a time, and what's important is that you check it before you squared the problem. So I'm going to plug into this original of sine x equals cosine x. So if I check pi over 4, I'm going to do sine of pi over 4, and that should equal cosine of pi over 4. We have to actually evaluate this in order to check that. Pi over 4 is a 45, 45, 90. All of these are going to be. So their values are all going to be the same, but what you're going to notice is your positives and negatives will change each time. So this is in quadrant 1. So sine in quadrant 1 is positive 1 over root 2. Cosine of pi over 4 is positive 1 over root 2. So this checks out. When I do the 3 pi over 4, you plug it in again to both of them. That is quadrant 2. So now sine is still positive 1 over root 2, but cosine is negative in quadrant 2. So this does not work, and we will cross off 3 pi over 4. Going on, you're going to do the next one then. So sine of 5 pi over 4 equals cosine of 5 pi over 4. That is quadrant 3, which now means they're both negative. So that does in fact check out. Lastly, it's going to be 7 pi over 4. And that should be equal to cosine of 7 pi over 4. These are in quadrant 4, which means sine is negative, cosine is positive. That does not check. So your only two answers are pi over 4 and 5 pi over 4. Again, the reason we had to check this was because in the original part of the problem we squared both sides. And so you have to do that here. Write this one down. We're going to give it a try. Oops, this is supposed to be online on your notes. I have it as a negative. You can solve it either way. It's just going to change which ones check and don't check in the end. Again, I have sine and cosine added and subtracted together, and so I do want to make them squared so that I can hopefully condense them. So I'm going to square both sides of the equation. when you square the left side, sine squared x plus 2 sine x cosine x plus cosine squared x equals -1. What you'll notice, sine squared and cosine squared is 1. So this is 2 sine x cosine x plus 1 equals equals +1. When I squared that 1, it became positive. You can isolate this, and this will be 2 sine of x cosine of x equals 0. Now you have kind of two paths here depending upon what you want to do, but what is often the easiest is to notice that this is a double angle identity. So this is really equal to sine of 2x, and you're doing sine of 2x equals 0, and you're going to do this just like you did day 1. As a side note, this is not the only way you can do it. Since you have multiplication set equal to 0 right here, you could just set your factors equal to 0. You're going to get the exact same answers, but I warn you not to do that if it's equal to anything except 0. So if it's set equal to, if it's 2 sine x cosine x equals literally anything except for 0, you have to turn it into a double angle, which is why I will recommend you do it anyways. So moving along, you're going to solve for sine of 2x. So sine 2x equals 0, so that is your y over your r. When you do that, that's going to be 0 and pi. The 2 tells you to do 2 revolutions, so it's 2 pi and 3 pi. Dividing by 2, you're going to get 0, pi over 2, pi, and 3 pi over 2. We do have to check this, though, because we squared both sides. And again, mostly what you're going to be checking is your signs, but I will go ahead and write it out over here. When we plug them in, you're going to do sine of 0, plus cosine of 0, and see if that equals -1. When you're evaluating this, sine of 0 is 0, sine of cosine is 1. That does not equal -1, so 0 gets crossed out. 1 plus 0 gives you +1, not -1. Pi over 2, you're going to do sine of pi over 2 plus cosine of pi over 2 and see if that equals -1. Sine of pi over 2 is 1, cosine of pi over 2 is 0. That does not equal -1, so again I cross that one out. Sine of pi plus cosine of pi. Sine of pi is 0. Cosine of pi is -1. That does equal -1, so this answer checks. And lastly, sine of 3 pi over 2 plus cosine of 3 pi over 2. Cosine of 3 pi over 2 is -1. Cosine of 3 pi over 2 is 0, so this one does check. So my two answers are pi and 3 pi over 2. On some of your homework problems, when you have to check it, it will be ratios or exact values that you don't know how to find without using a sum and difference. On your test, I have made sure that anything you have to check is going to give you nice answers like this one. So when you're doing your homework, yes, you might sometimes have a sum or difference. Feel free to use your calculator to check those answers. On your test, it will be ones that you can plug in. So it will be a 45, 45, 90, a 30, 60, 90, or a quadrantal. So just know you will have to check like this on your test without a calculator. Give you one more right here, just like this. Again, there's multiple different types, but most of the time you're looking to see if you can use a double angle. Looking at this problem, it's already squared, so I don't have to square both sides, which is nice because that means you will not have to check this problem. Thinking of our double angle identities, I know that cosine squared minus sine squared is cosine 2 theta. So what could be helpful is to subtract that sine squared over. It's going to be 0 then equals cosine squared x minus sine squared x. And then I can say, cool, this is cosine of 2x. Going then about the rest of the problems just like you did on day 1. 2x. For cosine of 0, that's going to be pi over 2 and 3 pi over 2. Remember, you want a second revolution, so that is going to give you 5 pi over 2 and 7 pi over 2. If you add 2 pi to each of those, dividing everything by 2 is going to change your denominators to 4. And so my answers are these. Again, I do not have to check this. I didn't square both sides. I didn't have a fraction that I canceled out. Nothing like that at all. Okay. The last thing you're going to do, we are going to have to kind of do together in class, but in the event you have a graphing calculator at home, I wanted you to have the chance to do this. I'll show you how you do it on Desmos, but you will not get to use Desmos on your test. So I would just write these steps down, and I'm going to then use Desmos to show you kind of how to do this, because there are problems we're going to solve on the graphing calculator. It will be the first portion of your test. There will just be 2 questions that go over that. But you will have to know how to do it on a graphing calculator. So again, if you have one at home, I strongly recommend using it. If not, you can use Desmos on your iPad for now to get the idea behind it conceptually, but you still will want to learn the actual steps for typing it into a graphing calculator, which we will do together next class. So, for example, you have this problem. In order to type anything into a graphing calculator, you have to have it equal to 0. One thing I'm just going to point out to you off to the side of why we would have to use a graphing calculator for this one. In the event you tried to solve this, you would have sine of x equals 2 over 3, because you would divide that. This is not a special right triangle. So you would have to work with a calculator to do it, whether you just use your arcsine function to do it, and then figure out your multiple quadrants. So since this isn't a special right, we would need a calculator for this, which is why I'm going to give you one. We do know there's a value for this because this is less than 1, and remember that as long as sine and cosine are less than 1, since this is your opposite and this is your hypotenuse, that means that there is an angle that has that trig function. So again, to type this in your calculator, it has to be equal to 0. So I'm going to move that 2 over. It's going to be 3 sine of x minus 2 equals 0. I'm going to switch on over to Desmos, which again, you should have this on your iPad. I'm going to just type in y equals 3 function sine of x minus 2. It's going to give you a couple of instructions. One thing is that it will tell you it only wants the answers from 0 to 2 pi. So what we've talked about before vaguely is that your sine functions keep going. We're going to graph next chapter, so you're going to know this. It keeps going because it's finding every single coterminal angle, and you're going to notice it's very periodic in this for the function. But I'm only going to want the answers from 0 to 2 pi. So on Desmos, you can see your answers. The nice thing about Desmos is you can touch those zeros and see. But when I'm touching the zeros, it's giving me multiple, and I could keep touching them and getting more and more zeros for this function, but we only want them up to 2 pi. On your calculator, you're going to be able to tell it to set from 0 to 2 pi in your window, and we'll show you that again on Monday. But if you think about it, 2 pi is about 6.2. So that means that the only answers that I do want for my intercepts, or my zeros, is where it actually hits and it's less than 2. So the only answers I am going to have are going to be these 2 right here. So when you do this, you'll set it equal to 0. You're finding your zeros. And then the graph will tell you that it was 0.73 was one of them, and the other one was 2.41. So those would be my 2 answers within the region of 0 to pi over 2. Or sorry, 0 to 2 pi. Here's just another example. I made it a little bit uglier because there will be some where you have to be able to know how to type some more complicated things into your calculator. When we set it equal to 0, it's going to be tangent squared of 3x minus the cube root of 5 minus cosecant of x. And your calculator isn't as smart as you, so it doesn't know all of these things. So one thing you have to realize is that this tangent squared of 3x, when you type it in, you're going to have to do tangent of 3x and then square it, because you cannot put the squared right on the tangent in your calculator. We're going to have to do the cube root of 5. There is a cube root button on our calculators, but one thing you can also remember is it's 5 to the 1/3 power, in the event you can't remember how to find that cube root button. And cosecant is usually not a button on your graphing calculator, and so we can use our reciprocal and say this is 1 over sine of x equal to 0. Then we can go ahead and find our zeros or our intercepts of that function. So a lot of this is just knowing how to type whatever you have into it. So again, I'm going to switch over to Desmos. Go ahead and get rid of this one and type in my new function. So y equals, Desmos does have a cosecant if you'll notice, but I'm not going to use it because I want to make sure we know how to type it in on our graphing calculators. So tangent of 3x, and then I'm going to square the whole thing, minus 5 to the 1/3. and then minus 1 divided by sine of x. This one is quite pretty, if you'll notice. One thing I did do on the directions, I forgot to write this down on the Jamboard, I apologize for that, is I said you only have to go to pi over 2, because if you'll notice there are so many answers from 0 to that 0.68, so approximately what I'm showing on the screen, you would have all these answers. So on your test, I'm only going to have you go to pi over 2. Pi over 2 is just a little bigger than 1.5. So let's check. So that would be done. So my answers would be the 0.376, the 0.692, and the 1.389. So again, you're setting it equal to 0 and then just finding me those intercepts within the region that I ask you to find it in. And that's all of it for your special cases.